Have you ever traveled down a road in a car and looked at the mountains or hills in the distance? If you have, you've probably noticed that while nearby trees quickly fly past the window, the mountains move much slower, and in the far distance, the moon and the stars don't seem to move at all. As you move, objects closer to you, such as the trees, seems to shift position relative to more distant objects, like the mountains. This effect is called parallax. The size of this shift depends on the distance you travel along the road and how far away the trees are. The closer they are to the road, the bigger the shift. The same thing happens as the Earth moves around the Sun. Over the course of a year, some stars appear to move a very small amount relative to other stars. Like the trees along the side of the road, these stars are just closer than those that don't seem to move. Actually, all stars are moving through space, but much more slowly than parallax, so we don't notice. Now, if we measure how much a star moves when the Earth does one complete trip around the Sun, we can use this to work out this angle, called the parallax angle. If we observe a star when the Earth is at one spot in its orbit, and then wait 6 months for the Earth to move around the Sun to the opposite point along its orbit and observe the star again, we can measure the parallax angle. Since we already know the distance from the Earth to the Sun, we can now use this parallax angle and some trigonometry to work out exactly how far away the star is. This is really useful because it allows us to calculate the distance to nearby stars very accurately. This can then be used to check the distance measured by different methods to even more distant objects out in space.